Welcome back. In the next few lessons, we'll go over several ways to externally save data with the NumPy package. In this lecture, we'll use a function called npsave. It stores the data in a special file type called npy. Okay, before we begin, we need to ensure two things. One, that NumPy is imported, and two, that we have a dataset in Python at hand that we wish to store in a file on our computer. So let's import the package first. Okay, next we'll define a variable called lending company and set it equal to the generateFromText function. We'll use it to import data from the lending company saving CSV file. It uses commas as delimiters. In addition, to preserve as much of the data as possible, we'll import the file as a string in NumPy. This operation will allow us to have the lending company data in an easy-to-work-with form in Python. This ND array will also be the dataset in Python that we want to store on our computer. Even though we're only importing the dataset so we can store it, good practice dictates we must display the array after importing it. Fantastic! Now, let's move on to saving this piece of information on our machine. That means we need to turn our attention to the npsave function. So, the two arguments this function requires are the name of the file we want to create, in quotation marks, and the dataset we wish to record, specified in that order. For the name of our file, we'll try to stick to our naming conventions, so we'll pick a name that clearly depicts the data we're storing. Make sure to separate the words with dashes rather than underscores, as we want to have a clear distinction between variables and files. Besides, you don't need to add an extension of the file here, and we'll explain why in just a moment. As per the dataset, we just type out the name of the variable we used to store the CSV file earlier, lending company. Let's execute this line of code to create the relevant npy file. Right. So, the npsave method creates an npy file in the same directory as your notebook document. This npy is a special type of text file native to NumPy and has several advantages over alternatives like txt or CSV. For starters, the npy is much faster in the sense that it loads a file containing 10 million values 20 times faster than a corresponding CSV. Similarly, npy files take up way less memory space than their CSV and txt counterparts. These factors mean that they are faster to work with and more compact too. Of course, these advantages can be applied to data that is relevant for computations in NumPy only. CSVs and other text files are still extremely useful when preprocessing and analyzing data with other libraries or programming languages. Before we proceed with our discussion on the npy files, I'd like to stop for a second to examine a very important distinction. When we say load a dataset, we do not mean import dataset. The difference is importing doesn't keep track of the data type of the original array. That's why we may need to specify or modify the data types of the values after having brought them into Python. As opposed to this, when loading, we don't need to specify or change our data while working with our Python object. The relevant Python tool will have taken care of this and brought the dataset into a state we can directly work on. That's why, in my opinion, the most convenient feature of npy files is that since they are native to NumPy, the entire dataset keeps its format. So, we don't need to worry about specifying and reorganizing the values from the external text file. For example, say we store certain parts of the dataset as numbers. Even though npy is technically a text file, when we load the dataset back into Python, it will consider them as numbers automatically. To showcase what we mean, let's boot up the npy file we just recorded. We can call the npload function and in parentheses, write the name of the file, extension included, surrounded by quotation marks. Since this loads the data, it keeps any format we set to the lending company array prior to saving it into an npy file. Because we like seeing the fruits of our labor, we also want to print the variable that stores the loaded data. We still have the original file displayed on screen, and we can immediately tell they are similar. However, if we want to make sure they are identical, we can use the npArrayEqual function and plug in both datasets as inputs. The outcome states true, So they are indeed the same, which is great. It means that the data is unaltered after we saved it and loaded it back in. All right, now that we know how to use NumPy, we can explore other ways to externally store data. In the next lecture, we'll introduce a different NumPy function for saving Python data into files, NumPy saves. Thanks for watching.